Hello learners, you are welcome to another class of practical physics. My name is Viekwaso Semakula Samuel. I am a teacher of physics. In this class, we are going to carry out an experiment to investigate what happens when a reflecting surface is rotated through an angle. What happens to the reflected ray? In short, we want to find the result of rotating a reflecting surface through an angle theta. What happens to the reflected ray? So in this experiment, we are going to use a softboard. We have a mirror here, which is our reflecting surface. We shall have a tracing paper. We are going to use optical pins to help us trace out the incident and the reflected rays. Then we shall use a protractor to measure the angles and a ruler to draw the lines. So we begin by sticking the tracing paper onto the softboard using the thumb pins so that it does not move during the course of the experiment. Then we shall get our reflecting surface, which is the mirror, put it vertically on the tracing paper, and then draw a line, which line is representing the mirror. In fact, this can be called the mirror line. So we remove the mirror and we mark out our point of incidence. So we put a small mark to represent the point of incidence. Next, we are going to draw the normal. Why? Because angle of incidence and angle of reflection are all measured from the normal. So we are going to put our protractor and draw the normal. We measure an angle of 90 and draw that line, which is called the normal. The normal is perpendicular to the reflecting surface. We are going now to choose an angle of incidence. So using the protractor again, we are going to choose and draw, to choose an angle of incidence and then draw the incident ray. We can choose an angle of 30 degrees. So this is 30 degrees. So we now use the ruler to draw this line, making an angle of 30 degrees with the normal. So that line is representing the incident ray. So right now we have the mirror line, we have the normal and the incident ray. So we now put the mirror back on the mirror line or along the mirror line, and then we stick two optical pins vertically along the incident ray or the line that is representing the incident ray. Now, viewing from the other side, we are going to stick two pins such that they appear to be in line with the images of the pins we stuck on the incident ray. So we need to look through the mirror on the opposite side of the normal with one eye closed with one eye closed, we place the pin, place the second pin such that it is in line with the pin we placed first and the two images in the mirror. So with one eye closed, we place that pin, and when you look at that pin directly with one eye closed, it is covering the other three, which is the first pin and the two images. That means that they are in one straight line. So next we remove the two pins, we remove the mirror, and when we draw a line representing the reflected ray. We draw the line representing the reflected ray. Next, we are going to rotate this reflecting surface through an angle. So we want to rotate this reflecting surface through an angle of 10 degrees. So we are going to measure an angle of 10 degrees here. We are going to measure an angle of 10 degrees So initially, this was the position of the mirror. Now we are going to rotate this mirror through an angle of 10 degrees to this new position. So with the mirror in this new position, we are going to determine the new position of the reflected ray. We put the pins back. Those are the pins along the incident ray. The incident ray is not changed, but we have changed the position of the mirror by rotating it about the point of incidence through an angle of 10 degrees. We now go through the same process of tracing out the new reflected ray. So we go to the tracing paper and we stick two pins. We stick two pins such that they appear to be in line with the images of the first two pins along the incident ray. So we have one pin there covering the other two images. With one eye closed, we place the other pin such that when you view, you see only one pin. We remove all the pins, we remove the mirror and draw the reflected ray along the points where the pins were stuck. So here we have the reflected ray. We have the first reflected ray when the mirror was in the first position. Then when the mirror was rotated to the second position, we have the new reflected ray. So we are going to measure the angle between the two reflected rays, which will be the angle of rotation of the reflected ray. So as we can see, this is the first reflected ray and this is the second reflected ray after rotating the mirror through an angle of 10 degrees. And the angle between those rays is 20 degrees. Therefore, the angle through which the reflected ray is rotated, which is that angle, is twice the angle through which the mirror is rotated. If the mirror is rotated through an angle theta, the reflected ray will be rotated through an angle 2 theta.